Good evening to all. So this is Kumar from SNS College of Technology and the Department of Computer Engineering. So now I am going to tell about what is deadlock and deadlock detection and recovery in operating system. So deadlock detection. So we have three type of deadlock detection state. So allow system to enter deadlock state and a detection algorithm and recovery scheme. So the system may provide an algorithm that examines the state of the system to determine so whether a deadlock has occurred. So an algorithm to recover from the deadlock. Single instance of each resource type. So maintain a wait for graph. So nodes for process and the PI tends to PJ. If a PI is waiting for PJ, so periodically invoke an algorithm that searches for a cycle in the graph. So if there is a cycle, then there is exist a deadlock. So an algorithm to detect a cycle in a graph requires an order of n to n square operations where n is the number of vertices in the graph. So resource allocation graph and wait for graph. So first one resource allocation graph, it will create a cycle and a corresponding wait for graph without cycling. So these are the different resource and different process with different resources. So we have 5 different process P1, P2, P3, P4, P5, and P1 request to R1, R1 request to P2, and P2 request to R3 and R4 and R5, and R4 request to P3, and P3 request to R5, and R5 request to P4, P4 request to R4. In a resource allocation graph, the P5 is alone in the edges, so the P5 first executed and then they report the P1. So in a corresponding wait for graph, so P1 wait for P2, and P2 wait for P5, P4 and P3, P3 wait for P4, P4 wait for P1. Okay. So several instances of a resource type. So we have available and allocation records. So available means a vector of length m indicates the number of available resources of each type, and allocation, an n into m matrix defines the number of resources of each type currently allocated to each processes. And request, an n into m matrix indicates that the current request of each process. If request of I and j equal to k, then process pi is requesting k more instances of resource type rg. So detection algorithm. So let work and finish be vectors of length m and n respectively. So and initialize. So work equal to available for I equal to 1 comma 2 and n. If allocation I not equal to 0, then finish of I equal to false. So otherwise finish of I equal to true. And find an index I such that both finish of I equal to false and request I less than or equal to work. So if no such I exists, go to step 4. So work equal to work plus allocation. So finish of I equal to true means go to step 2. If a finish of I equal to false for some I comma or 1 less than or equal to I or less than or equal to n, then the system is in deadlock state. So moreover, if finish of I equal to false, then PI is deadlocked. So algorithm requires an order of m into n square operations to detect whether the system is in a deadlock state or not. So example deadlock detection. So we have a 5 process P0 to P4. The resource type of A, B, C instance. So snaps of time equal to T0. So we have a P5 process and allocation and request and available. So sequence is a P0, P2, P3, P1, P5 is a result. So finish of I equal to true for all I processes. Example come to. So P2 requires an additional instance of type C. So we have a request of A, B, C. So if the system is safe or not. So can reclaim resource held by process P0 but insufficient resource to fulfill other process request. So deadlock exists and consisting of process P1, P2, P3 and P4. So detecting algorithm usage. So when and how often the invoke depends upon. So in this case we have raised two different questions. First one is how often a deadlock is likely to occur. Second question is how many processes will need to be rolled back. So one for each design cycle. So if detection algorithm is invoked arbitrarily, so there may be many cycles in the resource graph, and so we will not be able to tell which of the many deadlock process caused the deadlocks. So this is deadlock detection algorithm usage. So recovery from deadlocks is a process termination. So abort all deadlock process and abort one process at a time until a deadlock cycle is eliminated. So in this case, which order should we would choose to abort the deadlock? So priority of the process and how long process has computed and how much longer to completion, and resource the process has used and resource process needs to complete, and how many process will need to be terminated, and next one is process interactive or batch. So these type of function is used to terminate the deadlock processes. So selecting a victim and rollback and starvation as the recovery from a deadlock options. So starvation the victim is minimizing the cost, and rollback is a return to some safe state and restart process for the state. And the starvation is same process may always be picked as the victim, include a number of rollback is in cost factor. So these are the reference for deadlock recoveries and deadlock reductions. Thank you.